section is process scheduling in operating systems. The next slide. So process scheduling in operating system is a critical component of operating system that detects the management and execution of processes. Efficient scheduling improves overall system performance, optimizes resource utilization, and enhances system responsiveness, leading to an improved user experience. So basically, process scheduling is the way in which the processes are the CPU is attached to the process. That is the way in which process are given their every process is given a specific way in which before they operate. Next slide. So the process scheduling is a method by which an operating system decides the order in which processes execute to avoid any process lacking or to any process being stopped. So important of scheduling. Proper scheduling improves system efficiency, optimizes resource usage, and enhances overall system performances. So we have types of processes. Processes can be categorized into foreground interactive and background batch processes. Foreground interactive are like the processes that we interact with directly. They need quick response and the computer so that the computer won't feel delay. Examples are like typing in Microsoft Word, browsing in Chrome, using WhatsApp or Zoom. Why background batch processes? These are the ones that don't need direct interaction, like the software updates downloading in the background, virus and running while you work. The next slide. The scheduling algorithms is also how to say types of scheduling. We have the first come, first serve, FCFS. It's a simple scheduling algorithm where processes are executed in the order they arrive. This can lead to the convoy effect, impacting performance negatively. So for this scheduling algorithm, it's according to how the process comes in. So the first process that comes in is the first process that's going to be that's going to execute first. Yeah. So while the shortest job next prioritizes processes with the shortest execution time. And while it minimizes average waiting time, it can lead to starvation for longer processes. So like when process comes in, the process with shorter time are executed first before those with longer time. So this method somehow starts longer processes. While the round robin the time sharing scheduling method that assigns a fixed time slice to each process. This is a fair and suitable time sharing system, but the time slice must be carefully chosen to avoid inefficiency. Sorry. So this round robin, it shares it accordingly, like equally. So for this scheduling process, there are no processes being stopped. Everything is given equal time according to the time each process is going to take to execute.
Next slide. So now we're talking about the advanced scheduling techniques. So the first thing we need to talk about now is priority scheduling. This assigns priority levels to processes, allowing higher priority tasks to be executed first. However, it can lead to starvation of lower priority processes if not managed properly. This simply means that when we are doing priority scheduling, that the higher one is going to be attended to first. Let me give an example now. In the hospital now, if you go for treatment and you have an emergency case now, those ones are attended to first. So same with the computer, the higher priority tasks are executed first while the lower ones are attended to after. Then we also have the multi-level queue scheduling. This divides processes into multiple queues based on specific criteria, e.g. priority, process types. Each queue has its own scheduling algorithm, optimizing performance for different tasks. So this simply means that in the multi-level queue scheduling, that every process is divided into queues based on the criteria so that it could like process it efficiently. Then the next thing we have is the multi-level feedback queue. It's an advanced version of the multi-level queue scheduling that allows processes to move between queues and based on their behaviors and requirements, providing flexibility and efficiency. But this one is just like the multi-level queue scheduling, but the difference is that this one is more advanced than the previous one. This one allows processes to move between queues based on their behaviors. Like in an instance now, me and like let me give an like let's say we are sharing food now. I'm hungry, you're also hungry. But I've eaten earlier in the morning. So me that I've already eaten. No, Mr. President,
We're in a presentation now. Will come. Somebody will come.
so in an instance where we are sharing food now, and I ate in the morning earlier, and someone that I've not eaten at all, but we are both hungry. Me that I already ate, I want to be attended to first. It's the person that hasn't eaten that we are attended to. So that basically what this sums up. Next step.
So come. Can go and meet him.
I need to take this thing.
What?
This gentleman. Because I have to start already.
No. It's in ES office. He's attending a Zoom meeting.
Okay, this one.
12 o'clock. Yeah. Okay?
So real-time scheduling. Real-time scheduling is essential in systems where meeting deadline is critical. Understanding different scheduling algorithms such as rate, monotonic scheduling, RMS, and earliest deadline first, EDF. And this helps in optimizing process execution with strict timing constraints. So first we need to talk about real-time system. So real-time systems are the processes there must be executed within strict time constraints. So in real-time systems, tasks don't just need to be correct in logic. They also need to be finished within specific time and its deadlines. So as the task is going to be correct, it also needs to be finished within a particular deadline. So it does not cause problems. Like for instance now, we have a car now. Like our car airbag system now, if an accident happens, the airbag needs to be deployed in milliseconds to avoid damages to the person. So in that sense now, the real-time system now works that same way. You need to be active and also be correct. So it does not waste any time. It works like in real time, like the name defines. Then we also have the rate monotonic scheduling, that's the RMS. That one is the fixed priority algorithm for specific tasks. So the RMS now is just like a rule where shorter tasks always gets more priority. So in an instance now, the tasks now, we have two tasks. The first one run for like 5 meters per second. The second one run for like 8 meters per second. The RMS now is going to prioritize the first one that runs for 5 meters per second because that one is going to finish fast. The rate is like faster, so it prioritizes the first one. Similar to the rate monotonic scheduling, we have the earliest deadline first. This one is like similar to monotonic rate monotonic scheduling, but the difference is that this one is dynamic, it's interactive, it changes. So the earliest deadline first is more flexible. Instead of looking at the periods, which is the time, the rates it takes to complete the task, this one focuses on the deadline that the task is assigned to. Like similar in an office here in NEITI now, we have different departments and we have different taxes. So the task that is assigned to an office that is supposed to deliver the next day now, it's not going to be prioritized over the task that is supposed to deliver that moment. So that's that for earliest deadline first. Then we also have addressing scheduling, we have the CPU burst time, the IO operation, and the system load. So the CPU burst time now is the accurate prediction that can improve scheduling efficiency. This is the amount of time the process, which is the task, spent using CPU before it is like it either finishes the task that is given or it uses the IO, which is the input output. So a CPU burst time now, this is just simply just means the time that the
Recording in
system is going
progress.
to use to process a task
Recording stopped.
before needing the input or the output function of the computer system. Then the input output operation, which is the IO operations, this balancing CPU bound and IO bound processes is essential for optimal performance. This IO now just means the input and the output. So in the system process now, we use not just the CPU, we also make use of the input and the output, which is like the hardware components of the computer. So the input and output operations are tasks where a process interacts with the device instead of the CPU. So the input now, let's say reading from a keyboard, I think we all understand what input means. Like, an example now is in MS Word now, we are typing documents now, we are inputting information into the computer that's going to be stored and we read later. So, output now means the display, like the desktop, for example, now, and this device we're using to view now. This one is giving us output. So that's basically input and output. So now example now is downloading a file from the internet, and those one make use of the network. Make use of the input and the output operation. So before you can access the internet now, you need to make use of your hardware components, which is your input and your output devices. So in relation to the CPU, while the process is doing IO, which is the input and the output, the CPU can be free to handle another task. That's why CPU and IO bursts usually they alternate. That means they work hand in hand with each other. They switch places. Like for instance now, the process of the CPU now is performing a task now, which is like the CPU burst time now. It's performing a task. Then it reaches a point, because I explained earlier that CPU burst time just means the time the process is going to take place before it uses the input and output operation. So it reaches a point now and it needs the input and output. It's going to stop there. Then it's going to request for the input and output operations. So when it receives the required data from the input and output, then it's going to process it, then it's going to continue the process that is undertaken. So then we have the system load, which it takes high load. It may require more sophisticated algorithms to maintain performance. This one is the amount of work the task the CPU is handling at a given time. So the system load now just means that the amount of work that the CPU is going to process at a given time. It works with time because everything is calculated. So it's measured as the average number of processes waiting in the ready queue. So in the computer now, there's what we call a ready queue now. That's where the processes are being stored before they are executed. So if too many processes are waiting, the system is said to be heavily loaded. Same with your systems or your phones. If too many programs are open, your phone is going to start lagging. It's going to be slow because it's overloaded. So same with system load now. If you have too many systems waiting in the queue, it's going to cause a system load. Next slide. So in conclusion, the conclusion on process scheduling, we are going to be reviewing three major things: the impact of scheduling on performance. So scheduling now is its effective process of scheduling directly influences system performance, user satisfaction, and resource utilization. So what this means now is that in scheduling, the processes is not all we are looking at. That if a process is taking place and the process is like not it's not done correctly, it's going to influence the overall performance of the system. Because like I said earlier with CPU burst time, if a process is going on and is asking for input output operations and is not being given data, it's going to cause what we call a deadlock. So that deadlock now is going to like delay the process until it's resolved and the process can continue. Then we also have the key takeaway. This is understanding this scheduling techniques is essential for optimizing OS performance and ensuring responsiveness. So we don't just need to be doing what we need to understand the scheduling techniques. So know which technique is going to be implemented for optimization and effective process. Then future trends. Scheduling algorithms will need to adapt to challenge like multi-core processors and real-time applications. So the future trends now is just telling us that when we are scheduling algorithm, there's something we call multi-core processors, and a very good example of multi-core processors is like our phones now. A multi-core processor is a processor that that is split into different components that work together to achieve um a task. So if this thing the multi-core processor is having issues, it's going to affect the overall functioning of the process and also the real-time application. So that's that for process scheduling.
Okay, that's good. Let's appreciate them. I really good. All right. Any questions? Process scheduling in operating systems. You repeated system, have so, okay.
The system I used to design is like it was showing correctly, but when I copied the file, so it's now having alterations, repetitions, and some other.
Oh, are they in pictures in
Yes,
a PowerPoint now?
yes, sir.
All right. Any questions? Okay.
If the execution time now is constant, like you have like two different programs that you want to execute. If the time now is constant, how do you prioritize the execution?
It's the same time.
And like is it the system that
You just choose, you can choose anyone.
the user can prioritize which one they want to use first?
The system we use default to look at to operate it now. Maybe the first that came to now take
Just like the
precedence.
first come, first out, we explain. The first one that comes is the one that's going to recommend.
Recording in progress.
Once it is not set that this is how you should do, so it will use the default.
Then there's also the priority scheduling now. If the tasks now, there are two tasks now, constant time. If one is like is prioritized more, that one is going to be done first, while the other one comes after it.
So how do you prioritize it?
And the system user is going to.
System user will need to set it, okay. So the main aim is to eradicate deadlock, right?
Yes.
Yeah.
But there are still chances of deadlock happening.
If you want to
Based on the
use
process.
Yeah, the processing speed. Yeah.
So in the presence of deadlock now, how are you going to
you know, you might not even
how are you
know
going
that.
to execute it now to prevent it from occurring again?
If you understand the system algorithm, the scheduling of that algorithm, so you're going to know the particular scheduling algorithm to use to avoid it.
What if it happens?
That means
Are you going to review the scheduling system or something?
and
Are you going to review the system again to see where the deadlock occur and then
You're going to
then
troubleshoot.
find the preferred scheduling algorithm to use.
What happens, you just do troubleshoot and look for the problem, then you resolve it from the problem.
And usually that's in programming. That's the reason why it's also always good to use if conditions. If this happen, do this. Because if you don't do that, it means that the system will just be blank at that time, nothing to do. So even if it cannot go forward, it will tell you that okay, I cannot go forward. Then you now press OK, then to refresh or do something. Any other questions? Our staff in diaspora. Okay. Yeah, okay. If there's no question on the comment again, then we will review the slides. We usually review. Yeah. Yeah, the first one, yeah, that's fine. But the repetition that we notice, yeah. No matter what, you should find a way out. In PowerPoint, okay, if I can actually cover this system because it's actually down. It's standalone. I can cover it with something that has color of that. You just put a triangle, a rectangle, paint it the same color, and it will cover. This one, okay, maybe let me do because if I try now, the recording point that I've set is okay. It still cover the place. Now I can just go to insert here and take a shape. This I will over it. Then I'll go to color, pick this, and pick the color in that environment. Then I'll say this. No, it look like something like this, or something like this. You can now find maybe a picture that depicts whatever you are talking about in our scheduling. You can go to insert and say icons. Let's see if there's anything scheduling. Okay, which one can cover that place among these ones? Calendar. You can still even put multiple. Let's say so if I did all this one together now, so okay, set them like this. Okay, it has arranged them. So somebody that is seeing it now will be looking at okay, maybe you just create a background for these three items. Yeah, so we will know that okay, maybe it's an error or something. Okay, on the second one, okay, I think it's okay. It's just only that you didn't align this. You should have used something like this. Yeah.
Recording
Okay.
stopped.
And the third one, yeah, it's still okay, but this white area is.
And then why do you have blue? You have pink. It's not limiting. There's blue for the first three. You now started having a peach and cream. From where?
Or even if you want to do it like this, you can stretch this blue, then the white can be in the middle, so that at least it will give it.
This one now looks like it's a separate thing. Separate.
Yeah, like a separate thing entirely.
Separate.
Yeah. Okay. And then here, this okay. It's just only your text. Go down. You cannot even see what you type last. Okay. So you should also, when you are drinking like that, you should also, just like this red line like this, make sure that you have something like this here and up here. that is guiding you not to go. Because once you put it in full screen, all those areas may be cut. So something like this on the four corners, you make sure that your text doesn't reach the place so that it won't be cut out. Okay, yeah, it's fine, but you should have put maybe those icons to depict whatever you are talking about. Yeah. Okay, you repeated the same design. Okay. Mm. You can actually repeat the same design. That's if it's more than one page. You understand? But this one is different from this one entirely. Yeah. And the last one, yeah, it's fine. But this color on blue is so out completely. All right.